Okay students, welcome back to another video. We will continue with the paper 4 of 0625 October November 24. We have done first 5 questions in the first part. Now from question number 6, it is saying that a student play violin near a doorway. This is a door in front of which there is a student who is playing a violin. And figure 6.1 shows a young teacher standing where he can hear the sound but cannot see the student. So teacher is behind the wall who can't see the student but can hear the voice of the violin. And these are the walls of the room. Part number A is saying stay the wave effect that allow the young teacher to hear sounds from the violin at the position he is standing in figure 6.1. So how is teacher hearing the voice? There are three effects that occur in sound: reflection, refraction, and diffraction. Firstly, in a reflection, the phenomena happens that there comes a wave which falls on a surface, and after falling and making some angle with the normal of the plane, it bounces back into the same medium, making the same angle with the normal. That means angle of incidence is equals to angle of reflection. The other process that occurs in sound wave is refraction. In refraction, we have two mediums, first medium and second medium. The wave hit the surface of the interface and then make some angle with the normal, and then it is refracted into the second medium, making some other angle with the normal. This time the angle of incidence is not equal to angle of reflection. Third one is diffraction. Diffraction have a hurdle in the path of waves with a gap inside it. This gap can be larger, greater, or equal to the wavelength of the wave that is coming. And what happens is this gap basically spread out our wave pattern. So it work as spreading of waves. This process is known as diffraction. In the question, we can see that there are not two mediums, there is no plane for which the waves can reflect. So the teacher is hearing the voice of the student via the process of diffraction. There is a gap of door. Question number 2 is saying calculate the frequency of the sound with wavelength 0.75 meter and the speed of the sound is 340 meter per second. The equation that connects sound frequency and wavelength is V equals to F lambda. I will arrange my equation with respect to F. It would be V over lambda. Lambda is wavelength. I'll put the values inside the equation. 0.75 is the wavelength and our frequency would be 453.3. Rounding it off to two significant figures will give you 450 Hz. Third part is saying a violin produces sound in the frequency range 200 to 3800. The width of the doorway is 0.75 meter. Explain why the young teacher hears the frequency calculated in part 2 clearly but finds a frequency of 3500 Hz much harder to hear. Okay, I'll just deeply explain the process of diffraction so you can consider the phenomena more well. For example, this is the door which has this 0.75 length, and there are wavefronts of wave that are coming towards this door. What happens is we know that the wavelength of the wave in first part were 0.75 and they are comparable with the gap of the door. So diffraction is more, or the waves are spread more if the wavelength of the wave that is going to fall on the interface of the gap is greater than the gap, or we can say the wavelength of the wave is comparable or equals to the gap, then the diffraction or the spreading of waves would be much greater. But if for this case 3500 Hz, we calculate the wavelength, it would be 0.097 meter. And this wavelength is much smaller than the gap. So for this case, our spreading or diffraction would be very less. So waves would be less spreaded. I am writing the answer over here. For frequency range 450, the wavelength is comparable with the gap. So it spread very well and the spreading is very good. So the teacher can hear it clearly. But for the frequency 3500, the wavelength is less than the gap, so the spread is not very good. So the teacher can't hear the student clearly. B part is saying a plane mirror is placed at the point X so that the teacher can see the student on figure 6.1. Draw a light ray from the violin to the point X and from point X to the teacher. Draw and label the mirror. Add an arrow to the ray to show how the teacher sees the student. Use ruler and sharp pencil for this drawing. Let's go to the diagram. For example, we have mirror at point X like this. And this orange line is the normal of the mirror. I fall a light ray from the student towards this normal, and I will measure what is the angle of incidence of the light ray from the normal. I'll adjust my protector very carefully, and after adjusting it I see that my normal is and my ray are making 40 degree with each other, so I'll draw the reflected ray at 40 degree as well with the normal, because of the fact that we know in reflection the angle of incidence is always equals to the angle of reflection. So if the angle of incidence is 40 degree, the angle of reflection should also be 40 degree. And you can see that this teacher can see the reflection of the student in the mirror now. Seventh question is saying a washing machine has an electric motor and electric heater. Figure 7.1 shows a simplified circuit diagram for a washing machine. So this is a diagram over which we have a power supply and emitter. A heater has a resistance of 25 ohms and the power supply has an electromotive force of 230 watts. So the power supply has the voltage of 230 watts, and this is emitter and this is motor, and the heater above side which has the resistance of 25 ohms. Now the question is saying to state the meaning of electromotive force. Suppose we have a circuit on which we have a bulb and current is flowing from positive to negative. And let's suppose I have 1 coulomb of charge which when leaves the battery is full of energy, and when it reaches a point, let's suppose here, some of its energy is used up in heat because of the resistance of the wire, and when it passes through the bulb more of its energy is used because the bulb has used the energy in form of light and heat as well, or we can say sound as well. And when it returns at the end of the circuit, almost all of its energy has been used up in a complete round trip, and this energy that has been completely used is known as EMF. So energy or work done by 1 coulomb of charge in one complete trip to the circuit would be known as EMF. B part is saying state the potential difference across the heater. We know it's a parallel combination. The heater and the motor are connected in a parallel junction. And for parallel circuits, we have a rule that the voltage that is being supplied is equals to voltage across all the components. So all the components will receive the same voltage of 230 watts. Heater would receive the same voltage and motor would also receive the same voltage. So voltage across heater is 230 watts. Part number C is saying calculate the current in the heater. For the current we can use Ohm's law, which says voltage is directly proportional to current as long as resistance is constant. Arranging it with respect to current, it would be voltage over resistance. Voltage of the heater is 230 and the resistance is already given by the question 25. Dividing them both will give me 9.2. So the current in the heater is 9.2. The D part is saying that the current in the motor is 1.6 amperes. Determine the reading on the emitter in figure 7.1 and explain your answer. We know that it's a parallel combination, and in parallel combination the current entering the junction is equals to the current leaving the junction. So the total current would be equal to the sum of current 1 of the heater and the current of the motor, and emitter is obviously going to read the total current. So current in the heater is 9.2. We have already calculated. The current in the motor is 1.6. So the emitter will read up the sum of the current, which would be 9.2 plus 1.6, which will be equal to 10.8. And the reason is, in parallel circuits, the current entering the junction is equals to the current leaving the junction, or the total current is equals to the sum of current in all the components. Question number 8 is saying, a fishman uses high frequency sound waves to locate fish in the sea, shows the sound waves emitted from the board. So here is a board which is emitting the sound waves, and this is a seabed. Part number A is saying that state the name of the sound waves which have frequency greater than 20,000 Hz. So the sound waves in a range 20 and 20,000 are audible by normal human ear, and any sound wave which is greater than this frequency range is considered to be ultrasounds, and ultrasounds are not heard by a normal human eye. So the answer to this question is ultrasound. B part is saying high frequency sound waves travel from the board through the sea water. The speed of the sound in the water is 1500 meter per second. The seabed is 22 meter below the board. Calculate the time taken for the board to receive the reflected wave from the seabed after the sound is emitted. So we have to get the time the wave take to reach back the boat. The speed of the sound is already given by the question, and the depth of the sea is already given. So time taken is always distance traveled over speed. Let us just consider this in the diagram. The depth of this sea is 22 meters. Sound waves will fall to the seabed, travel distance of 20 meters, and they will be reflected back to the board, and again they will travel the distance of 22 meters. So the total distance is 44 meters, and the speed of the sound is 1500 meters, and we have to get the time. So we'll put the values in this equation: 44 over 1500, which will be equal to 0.029 seconds. Writing the answer in the area provided. Question number C is saying figure 8.2 shows a fish below the board. So this is a fish. And describe and explain how the reflected sound wave received by the board from the fish differs from the reflected sound wave received from the seabed. So how these two waves, reflected waves, are different. For example, these are the waves that are being reflected by the seabed, and this fish is very small as compared to seabed, so it will reflect very few amount of waves, and the seabed will reflect very large amount. Also, the fish comes before the seabed, so it will reflect the waves earlier than the seabed, and they will reach the boat earlier. So the answer is, as fish is very small, so very few sound waves will be reflected back by the fish, and also the reflected waves will reach the boat earlier than 0.029 seconds. Question number 9 is saying that figure 9.1 shows a wireless charging plate used to charge the battery in a mobile phone. The coil of the wire is a part of electric circuit. So this is a charging plate on which we have wrapped some conducting coil. The charging plate is connected to AC power supply, and the power supply is turned on. Describe the magnetic field around the charging plate in terms of magnitude and direction. So one thing is clear, as the coil is connected to AC power supply, so it's a changing current. Changing current will obviously produce a changing magnetic field. So changing magnetic field is produced due to the AC current. Other thing is very obvious fact that the magnetic field will be stronger near the coil, and as we go away from the coil it will get weaker. B part says a mobile phone is placed on charging plate as shown in figure. The coil is in the mobile phone is part of a separate circuit that charges the battery. This is a charging plate. The coil on the mobile is secondary coil and the coil of the plate is known as primary coil. And the coil is in the charging plate and the coil in the mobile acts like transformer. These two coils are acting like transformer. Explain why there is current in the secondary coil. For this, we need to consider the principle of transformer first. In transformer, we have two coils. First one is known as primary coil and the other one is known as secondary coil. And these two coils are wrapped on an iron core that strengthen the magnetic field of the coils and also concentrate the magnetic field. The primary coil is connected to alternating current. When the current flows, the flowing of current will produce a magnetic field around the solenoid. This magnetic field will also pass through the secondary coil as it's alternating current, so the magnetic field will also be changing magnetic field. Changing magnetic field produce a changing magnetic flux in the secondary coil, and obviously when the flux changes there is EMF produced and there is so the answer is AC current produce changing magnetic field in primary coil. This field change the magnetic flux in the secondary coil and change in magnetic flux will produce EMF in the secondary coil. Second question is saying suggest why the transformer made from charging plates and mobile is not 100% efficient. I've already told you that the coils are wrapped around an iron core. If the iron core is missing, the magnetic field will not be strengthened and will not be concentrated. So the efficiency won't be 100%. C part is saying the mobile phone battery can be recharged using this charging plate and stores 4.5 10 raised to power 4 joules of energy when it is fully charged. The current in the secondary coil is 0.63 amperes. This is the current in the secondary coil and the output voltage is 12 volts. Question number 1 is saying calculate the time taken to fully recharge a complete uncharged battery. Question is asking for time. Energy is given, current is given, voltage is given, and the equation that connects energy with current, voltage, and time is energy equals to IVT. Arranging it with respect to time will give you this. I'll plug in the values. The current is 0.63 amperes and the voltage is 12 volt. Putting all these into your calculator will give you 5952 seconds. Rounding it off to two significant figures will give you 6000. Second part is saying calculate the charge passing through the battery in 60 seconds. The charge and time can be connected by the equation I equals to Q over T. Arranging it with respect to charge will give you current times time. Current is 0.63, time is 60 seconds. So the charge would be 37.8 coulombs. Round it off and you'll get 30. Question number 10 is saying carbon 14 is a radioactive isotope of carbon. Carbon 12 is not radioactive. Part number 8 says explain how atoms of carbon 14 differs from atom of carbon 12. We generally when we write any atom on bottom left side we write atomic number, and atomic number is basically number of protons that are present inside nucleus, and over this side we write mass number of an atom, and mass number is the number of proton plus number of neutrons, and when you subtract mass number from atomic number you get number of neutrons. So these two have 6 protons, and to get the neutrons I'll subtract 14 from 6 and I'll get 8 neutrons, and for carbon 12 I'll get 6 neutrons. So carbon 14 has 2 more neutrons than carbon 12. B part says all organisms contain carbon 12 and carbon 14 and the ratio of carbon 14 to carbon 12 is 1:1 into 10 raised to power 12. Carbon 14 has a half-life of 5700 years When an organism dies, over no new carbon is absorbed. The amount of carbon 14 in dead organism remain fixed. So carbon 14 amount is not going to be changed. Why? Because we know the fact that carbon 14 is a stable atom. So it will not radiate and it will not decay, so its amount won't change. Describe how the amount of carbon 14 in dead organisms decreases. We know that carbon 14 is radioactive, it is unstable. So it will emit radiations and it will radiate and its amount will get reduced day by day. But the question is saying how the amount of carbon 14 is changing with time. We know that the half life of carbon 14 is 5700 years. So after every 5700 years, its amount will be get halved. So this is the pattern of changing. Question number 2 is saying a sample of wood contains carbon 14 to carbon 12 atoms in ratio 1:4. Calculate how many years ago the tree died. Initially, the ratio was 1:1 into 10 raised to power 12, and after some time, this ratio has been converted into 1:4. So firstly, the amount is always 1. After first half life, the amount is reduced to half. That means 1/2. After second half life, the amount is reduced by 1/4. After third half life, it is 1/8. After fourth half life, it is 1/16, and it continues. So from 1 to 1/4, there are two half lives that have been passed. So two half life means 2 times 5700 years has been passed. So the total amount of years is 11,400. C part is saying other radioactive isotopes have different half-life. Suggest the use of radioactive isotope with half-life of 1 year and explain how this short half-life is suitable for us. So we can use these type of materials in medical imaging because they are less harmful for human bodies. 11th question is saying state the name of one planet that has an orbit further away from the sun than Venus. So the any planet that comes after Venus, there are many planets. Firstly it comes Mercury, Venus, Earth, then Mars, then it continues. So you can name any planet after Venus. I am naming Earth. Second question is saying state the name of one planet that has an orbit closer to the sun than Venus. So any planet that comes before Venus, it's always Mercury. So you can write Mercury over here. B part is saying that Venus has an average radius of 1.1 into 10 raised to power 11 and the orbit speed of 20 to 20 Earth days. Calculate the average orbital speed of Venus in meter per second. Orbital speed can be calculated by the formula V equals to 2 pi r over t, and t is the time taken by the planet for one complete orbit around the sun. Putting in the values, r is given by the question, t is also given by the question, but this is in days, we need it in seconds. So I'll multiply it by 24 and then 2 times by 60 because days have 24 hours have 60 minutes, and 60 minutes have 60 seconds. So I'll write all these things over here, and after putting all these into my calculator, I'll get 36361. Rounding it off will give 36,000. C part is saying state the relationship between the orbit speed of the planet and distance from the sun. So if this is a sun and this is a planet orbiting in an elliptical pattern, when the planet is closer to the sun, it has more kinetic energy. As it moves away from the sun, its kinetic energy starts changing into potential energy, and as away from sun it has more potential energy, and when it start moving towards the sun, again potential energy changes into kinetic energy. More kinetic energy means more orbital speed. So the further away from the sun, the more slower the orbital speed is. Deepath is saying comets are balls of ice and dust. Some comets orbit the sun. State how the speed of comet changes as it orbits the sun. Explain your answer using the idea of conservation of energy. You may include a label diagram in your answer. So when a comet is closer to sun, I've already told you it will have more kinetic energy, and when it moves away, it will have more potential energy. So near sun, a comet has more kinetic energy, so it will orbit the sun faster. As it moves away, its kinetic energy converts to potential energy and its orbital speed is reduced. But keep in your mind that total kinetic energy and potential energy always remain constant, and they only keep interchanging with one another to conserve the energy. If the video was helpful, do hit the like button, and for more videos subscribe my channel.